Hi everyone, today let's explore something fascinating in optics, the prism. You might have seen pictures of a prism making a rainbow out of white light, but have you ever wondered how and why it does that? Well, by the end of this video, you'll know not only what a prism is, but also how it works, why it splits light, and where we use it in our daily lives. A prism is a transparent solid object, meaning light can pass directly through it. Usually made of high-quality glass or plastic, their optical clarity is key. Geometrically, a prism is any solid with two identical parallel bases and flat sides. It has flat, polished surfaces, crucial for guiding light without scattering it. While many shapes are technically prisms, the triangular prism is most common in optics. Its angled, non-parallel faces are what set the stage for its famous trick. Unlike an ordinary piece of glass, a prism has a special ability. When white light passes through, it bends twice, once on entry and again on exit. This double refraction separates the light into the 7 colors of the spectrum: violet, indigo, blue, green, yellow, orange, and red. This spreading of white light into its colors is called dispersion. It happens because each color is a different wavelength, and each wavelength bends at a slightly different angle as it moves through the prism. So why exactly does light split into a rainbow of colors inside a prism? The answer lies in what happens when light travels from one medium, like air, into another, like glass. When light enters the denser glass, it slows down. Imagine a car driving from a smooth road onto thick mud. It's forced to change speed. This change causes the light to bend, a process we call refraction. But here's the crucial detail. White light is actually a mixture of all the colors of the rainbow, and each color has a different wavelength. This means not all colors slow down and bend by the same amount. Violet light has a shorter wavelength, which interacts more with the atoms in the glass. It slows down the most, causing it to bend sharply. Red light, with its long wavelength, is less affected. It slows down the least, and its path bends more gently. This sorting process is called dispersion. As each color bends at its own unique angle, they fan out to create the beautiful, ordered spectrum we all recognize. This was first proven by Sir Isaac Newton in the 1660s. He used a prism to split sunlight into its constituent colors. Then, in a brilliant follow-up experiment, he used a second prism to recombine the spectrum back into white light, proving that white light is indeed a composite of many colors. If you've seen a rainbow in the sky, you've already seen prisms in action. Raindrops in the atmosphere act like tiny prisms. Sunlight enters the droplets, bends, and splits into 7 colors, creating a natural rainbow. Isn't it amazing that the same principle behind a simple prism explains one of the most beautiful sights in nature? Prisms aren't just for making rainbows. That beautiful effect hints at their true power, the precise manipulation of light. This ability makes them indispensable in cutting-edge science, advanced technology, and even in surprising objects we use every day. In optical instruments like binoculars and DSLR cameras, lenses produce an inverted image. A clever system of prisms inside uses total internal reflection to flip the image right side up. They correct the light's path, delivering the clear, upright view we expect. In spectrometers, prisms act as decoders for light. Scientists pass light from stars or chemicals through them, splitting it into a spectrum. Unique lines within this spectrum act as a fingerprint, revealing the exact elements present and unlocking chemical secrets. In fiber optic communication, prisms increase data capacity. They combine multiple laser beams, each a different color, carrying data into a single fiber. At the other end, another prism separates the colors again, sorting the information and enabling our high-speed internet. In medicine, beam-splitting prisms are crucial. In endoscopes and microscopes, they let a doctor both illuminate an area and view it through the same lens. This provides a bright, clear image, vital for accurate procedures and improving patient safety. The prism's principles are also in our daily lives. Beyond decorative crystals, specialized prism glasses correct vision problems like double vision. They even let people read while lying down. From scientific toys to the sparkle in jewelry, their light-bending magic is all around. Here are a couple of fun facts. Pink Floyd's famous Dark Side of the Moon album cover shows a prism splitting light into colors. Prisms don't just split light. Some are designed to reflect it multiple times inside, which is how many cameras and binoculars work. So to sum up, a prism is a transparent solid that bends and splits light into colors. It works because each color of light bends at a different angle. This simple object has helped scientists unlock the mysteries of light, given us instruments for astronomy, photography, and communication, and even explains natural wonders like the rainbow. Prisms reveal the hidden beauty of light, turning the ordinary into the extraordinary.